Hello and welcome everybody today. My name is Daniel Myers, developer advocate here at Snowflake. And today I am really excited for several reasons. One, we're going to be talking all about the new general availability of Pandas on Snowflake with the one and only Doris Lee. Doris, how are you today?
Hi, folks. My name is Doris Lee. I'm a product manager at Snowflake. Super excited for our live session today, where we're going to be talking about our new Pandas on Snowflake capability. So yeah, getting ready for some demos and like some exciting new, capabilities.
That's awesome. So, Doris, tell me a little bit about your background. Right, my understanding you're the co-founder of Modin. You're here at Snowflake. Tell me a little bit about your background.
Yeah, I actually started my career in astronomy and physics, and I actually did a lot of research with all these like amazing like Python data science tools. I used it to sort of do look at cosmological images, and one of the things I found out was, wow, it's like really hard for a domain scientist or someone who's not really coming from like a traditional kind of CS field to be able to work with data, especially large amounts of data. And so when it came time for grad school, I was like, hey, I actually want to go and like dedicate my time to do research on building tools for data science and data practitioners more generally. And so I started a lot of my research in the visualization and data exploration space. And then I did my PhD at UC Berkeley. We developed a couple sort of open source project there, one of which we will be talking about today is our open source project Modin, which is kind of a scalable distributed version of Pandas, which is really relevant to what we're going to be talking about today. And then after my PhD, I started a company called Ponder, which essentially is really, again, focused on this mission of how do we empower data practitioners to work with their data without additional complexity, without having to know all these things related to like distributed computing and all of that, but really allowing users to work with the tool they already know and love, namely in this case Pandas, and then sort of empowering our practitioners to be able to scale to more and more data. And so about a year ago, about 10 months ago, October of last year, we officially joined part of the Snowflake family. And so, myself, and our team here has been working really hard on this Pandas on Snowflake feature, and we're super excited to announce that yesterday. So fresh off the press, really exciting stuff.
Yes, I completely agree. Now, as we get into this and as we get into the demo and Pandas on Snowflake, tell me, for the audience here, what exactly are Pandas? What are they used for? And dive into a little bit of why this is so exciting.
Yeah, Pandas is probably one of the most popular Python data science tools that is out there. Right? It's this like really convenient tool that you're using for data transformation, ingestion, data loading, data cleaning, all sorts of stuff that you're doing with like tabular data. And the reason why Pandas is like really awesome is because it has all of these like APIs. For example, like you can drop null values, you can, group by, you can do all of these operations. In fact, Pandas has like 600 plus APIs. So it's like anything you can really think of like that you want to do with your data, there's probably a Pandas operation somewhere that you can use for that. And so I think this really like sort of opens the door for a lot of data practitioners to really work with, visualize, and like kind of see what's going on with their data, transform it, build data pipelines, and so on. But one of the challenges that we've seen a lot, especially for enterprise users, is that what Pandas is actually in-memory data structure, which means that when you're working with Pandas, all of your data needs to fit into memory. Now, that's probably fine if you're working with like several thousands of rows and like it's a CSV sort of data that's kind of like you download that from Kaggle or from GitHub or whatever. But if you're actually working with your enterprise data, you're typically working with like millions of rows, and then, and with the power of Snowflake, a lot of the customers that we've worked with, like they have their data in Snowflake, and these are not just like, a single table. They're like multiple table, like hundreds of millions of rows and so on. And that's not something that you can actually fit in your laptop, right? So the challenge is there is that then you have to kind of sample your data and only work with a small subset of your data, or you have to kind of take your pipeline and rewrite it into something that's a lot more scalable. And then so that really kind of hinders the time to value there in putting these pipelines and workflows in production. And even kind of being able to wrap your mind around like, hey, I want to just run some queries and get a sense of what my data looks like. For example, like df.describe is an easy way for you to kind of profile and look at, all of my columns in my Pandas data frame, and then, get an overview of my data. So that type of like, prototyping effort is really hard to scale as you're, starting to look at millions and millions of rows of data.
That makes a lot of sense. And so you wrote a blog post just yesterday, actually, was published yesterday. So I want to talk about that a little bit. So I have it up here on my screen. And what I want to talk about here is, the monumental performance difference, and dive into this a little bit more. So tell me kind of, summarize for me a little bit of what this blog post is talking about, and highlight for the audience some of the key moments.
Yeah, so the focus of this blog post really was to kind of talk about this new general availability of our Pandas on Snowflake feature. So the Pandas on Snowflake, again, is now the kind of the way that you can use the Pandas API and run that on your Snowflake data. What it's actually doing is it's taking your Pandas code, transpiling this down to SQL and then running it on the Snowflake engine. And so this is why it's super scalable, because Snowflake itself is very scalable. We've shown in this chart specifically that, if you look at on the x-axis here, we have, 1 gigabyte, 10 gigabyte, 100 gigabyte, and 1 terabyte, right? So different scales of data. And on the gray bar, we have the Pandas. And then on the blue ones, we have Pandas on Snowflake. And you can see just with the first two bars on the left, right? The 1 gigabyte and the 10 gigabyte. Pandas on Snowflake run so much faster, right? Like, look at the 10 gigabyte one, it's like 30x faster than what it takes to run if you were to do this in like vanilla Pandas. And the reason why vanilla Pandas is slow is that Pandas is single threaded. So even if you're throwing like, let's say my laptop, there's like 8 cores, you're really only leveraging 1 core. And so you still have to process through like that millions of rows in a serial fashion. Whereas with Pandas on Snowflake, we can leverage the underlying scalability and parallelism that is part of Snowflake and get that faster performance. Now, I want to kind of move your attention to kind of the right-hand side of this chart, right? We have these 2 other bars, 100 gigabyte and 1 terabyte. And you could see a gray bar there that shows Pandas doesn't even finish there. And what actually happens is if you try to run this same sort of representative workload on 100 gigabyte and 1 terabyte, again, like the data doesn't fit in memory. So at some point, you start loading the data in, and then your like whole Panda script, it'll just start crashing, right? Like it doesn't work. And so there's not really a good comparison point because Pandas just doesn't work there. And the goal of this chart is to show kind of 2 things. One is the speed, and then the other is on the x-axis, the scale in which we can operate. And namely, like if you look at the 1 terabyte regime, like again, like not everyone works with like a terabyte of data, but if you do, and if you want to run your Pandas queries on it, it actually takes less than 60 seconds. It takes less than a minute to run your Pandas code on more than a terabyte of data, which is a really impressive thing. It's one of the industry kind of leading sort of tools that are out there to be able to do this.
That's fantastic. And so you also mentioned, right, some of the key elements here, that it's built on Modin, right? The open source project Modin. And I have kind of the open source project here. talk a little bit more, just about Modin itself and kind of how it's related to this.
Yeah, so Modin is the open source project. We started developing this about 4 or 5 years ago at UC Berkeley. And Modin really started off with this idea of like, hey, how do we enable sort of data scientists to scale up to larger and larger data sets while keeping the same like Pandas semantics and abstraction. So you can see here with the import like animation here, instead of doing import Pandas as PD, you can replace that with import modin.pandas as PD. And then with one line of sort of replacement of the import statement, all of a sudden you get better performance in terms of, let's say, at the bottom here, you could see the read CSV, the null value, the applies. All of this is faster because Modin is able to leverage the underlying parallelism of your machine and be able to scale to larger data sets. And so our open source sort of Modin is designed sort of as a way for you to like be able to use the Pandas API. We support both Ray and Dask as the engine, and then recently we've added Snowflake as an additional option for that engine.
That's awesome. That's awesome. And so, so with this, I want to pass it to you to share your screen, and let's get a hands-on demo of this running and see for ourselves this performance improvement.
Yeah, let me pull up my demo. So the demo that I'll be showing you today is running on our Snowflake notebook. And so you'll also get a sneak peek at what it looks like if you ran. Are we all good with the screen share? Can you see my screen?
I can, yes. Awesome.
Okay, awesome. Yeah, so this is my Snowflake notebook. I have it open, and then I can very easily start using Pandas on Snowflake. The only thing I have to do, which I've already done, is if you go on, click on packages, I had to add in Modin as one of the installed package. If you are using Pandas on Snowflake locally, you also need to add in the Snowpark Python library, but this is already pre-installed on Notebook, so we don't have to worry about that. And so you can see here, I am changing sort of instead of importing Pandas as PD, I'm importing modin.pandas as PD. And then I'm also importing the Snowpark Modin plugin. So with these two sort of import statement, this is the only thing that you're going to see in this demo that looks more non-Pandas-y. Everything below, like, should be pretty, and then you also need the session because you need to connect to Snowflake. We also create a session here. And then within Notebook, it's easy to kind of get your active Snowpark session from that. Now, the first thing that I'm going to do is I have this financial time series data set from the Snowflake marketplace. And then I'm going to use pd.read Snowflake to read in this table, so stock price time series. I also did kind of a performance counter. I just took the start time and the end time to show the difference in time. So it took about 9.7 seconds for me to read in a table with more than 70 million rows. So that's pretty fast, right? Like, and the reason why this is really fast is it's not trying to bring all the data into memory. And I'll kind of show you what I mean by bring everything into memory, right? I'm going to run this because this command is actually going to take much longer. Now, I'm just going to let this run while we go back up and show you, if Pandas on Snowflake doesn't exist, what would you do instead? So there's actually two approaches that you would typically do. One is that you can create a Snowpark data frame using session.table. And so this looks very similar to what we have above. This is just a reference to that table. And then I store that as a Snowpark data frame. And then I can convert that Snowpark data frame to a Pandas data frame, to a native Pandas data frame by calling .toPandas. So that essentially takes my Snowpark data frame, serializes and like pulls all the data into this native PD underscore DF. The other approach that you could do is you could use our Snowflake connector for Python, run a SQL query. So you start a cursor, you run a query, you execute a query, which is like a select star, select everything from this data set. And then you call this fetch pandas all. And the fetch pandas all, again, takes the data that you have from Snowflake, pulls it all out, and then stores it in this Python variable called native pandas df. I think I did the second approach right here. You could see it's still running. It's been over a minute or so now. And again, if you scroll up, it only took 9 seconds for this this particular one to run. So again, even though this thing has not finished running, it is taking much longer than what it takes for us to do the read Snowflake command and reading my data into a Snowpark Pandas data frame. I'm going to stop this here because I wanted to be able to show the other parts of the demo. But again, this is what typically happens, right? Like you're working with your data, you run this like to pandas or fetch pandas all, and it's just really slow. Like sometimes you don't even know if it's going to fail, if this is going to crash. So it becomes a very frustrating experience, not just because there's like this, very expensive IO that's happening, but again, like you don't know when this stuff is going to finish, if it's going to crash, if it's going to be really slow. And so the next thing that I want to do is like, now that we have the Snowpark Pandas data frame, right? Like I can do all the stuff that that I want with the Pandas data frame. For example, I can do df.head, take a look at the first 5 rows. I can even use Streamlit to like take a look at the data frame itself and have this really nice data frame display. I can also filter my data. So again, this is a stock time series data. So I have this column called primary exchange code. And so I want to look at all the stocks that are in the New York Stock Exchange. So this is essentially a filtering step that is happening. And if you're familiar with Pandas, you'll recognize that this looks exactly the same as the syntax we use for Pandas. And again, all of this other code is just for timing purposes. And you can see that the filtering, again, on 70 plus million rows took about 1.8 seconds. This is what the filtered data looks like. So all the New York Stock Exchange ones. You could also do multiple filters. So I can look at Google, Microsoft, and Snowflake stock, and then the pre-market open price. And this is, again, the same filtering syntax as you would with Pandas. And also, I can do some reshaping. So I can do the reshaping with pivot table. So you can see that this is what the table looks like. So when I pivot the table, let me print out what the pivoted table looks like. The pivoted table essentially takes the ticker and the date as the index column, and then it extracts the value column. So if you go up here, you could see that there is a numerical value that is associated with the value column. What it's doing is it's kind of like reshaping the data so that you now have ticker and date on the indices, and then each of the values is listed here. Other things that I can do with my data is I can do data transformations. So I can do resampling, and this is really helpful, like especially when you're working with like time series data sets. So here, my resampling is done on a 91-day window. So that corresponds to like a quarterly window. So I can take the Google stock and the all-day low, and then compute the quarterly low across like a 91-day or a quarterly window. So here we can see that the resulting series is this is the quarterly low for each one of them. We used minimum as the aggregation. And again, this is exactly the same code that you would write if you were using the Pandas, the vanilla sort of Pandas API. And so the goal really with Pandas on Snowflake is you shouldn't have to change any of your code when you're going from like prototyping in a notebook all the way to working with like, tens of millions of rows, because it's the same API that you're using. Now I want to take this series and then run a diff on it. The diff kind of just allows us to look at quarter to quarter fluctuation. So it takes the diff across this series. And so this is what the differences look like. And finally, there's one thing that I want to show, which is Pandas apply. So Pandas is actually has this functionality called df.apply. And apply basically allows you to apply a particular function, Python function, across a particular axis. So in data frame speak, there is two axes. There's the horizontal axis, so you can apply things column-wise, or you can apply things like kind of row-wise. And so what I want to do here is I want to take my data frame, sort of the one that you saw here, which is the quarter by quarter low. I want to apply the absolute value square root on each of the values. And that is written as a sort of a Python function. And then we're just going to drop the nan value here. But you could see here that it's basically lambda x. I'm using NumPy to do the square root and the absolute value of the value itself. And what is actually happening here is that we're pushing down this compute to run on the Snowflake sandbox runtime. And then that allows us to kind of push this user-defined function down to kind of the engine level. So this is the resulting sort of series that is the absolute square root of value after the apply functionality. So finally, like with Pandas, you're obviously going to be like working with your data a lot. One of the most useful things I like to do after doing a lot of data transformation is just like taking a look at my data. What does my data look like? Especially useful when you're working with like time series and stuff like that. And so let's say if I want to plot my sort of visualizations based on this, this particular series, I can do a reset index, and then I also want to just like do some transformation. Like I want to rename some of the columns, remove some of the extreme values. And then the way that you would actually print out your Pandas, Snowpark Pandas data frame is you transform that data to Pandas. So you would call to Pandas to get a vanilla sort of Pandas data frame. And then you would show use Altair. So this is code with Altair to plot the bar chart corresponding to kind of the quarter to quarter fluctuation. So if you remember earlier, there were some negative values in that series. And so this is a very easy way that we can now start to see like across these different quarters, like, blue is the positive and then yellow is the negative. So again, like by working with your data using Pandas on Snowflake, the thing that I wanted to show in this demo is that all of the Pandas queries that I've written in this notebook is all just kind of the Pandas API. It looks exactly the same. But what's actually happening underneath the hood is you're working with 70 million plus rows of data. And all of that compute is actually getting pushed down to Snowflake. And so this is a very powerful way that you can now start to be able to work with your data. Because I think a lot of the times, like, we have our own preferred like languages. Like some people prefer using Python and Pandas. Some people are more comfortable with SQL. And so by exposing this new API interface, we want to enable Python and Pandas developers to be able to also work with their data at scale. And yeah, so that wraps up my demo. I'm going to hand it back to Daniel.
Fantastic.
Next steps.
Yes. And so that was an awesome demo. I loved how extensive you are able to show all the various capabilities. And like the highlight here is that if you're familiar with Pandas, you're familiar with this, right? And so it's It makes it more performant. It makes it a better overall experience when working with large quantities of data. And so that's a win-win by everybody.
Mhm.
So what I have here also on my screen here is the open source code of that demo that you just gave. And I think this is a big call out really for everybody watching. Exactly what you just saw Doris show, you can run that yourself in Snowflake today. And there's the entire quick start guide to do that. Here's the code for it. Um, and going from there. So like I think there's a lot of really good stuff here, and that people can go and see, and so that's good as a call out for everybody to get started. Now we are open for live questions as well. So for our audience today, let us know if you have any questions. And the first one actually coming in already. How does it work with file reading resides in an external stage?
That's actually a great question. So if you're familiar with Pandas, you're probably familiar with like read CSV, read Parquet. We do support reading from both a local path and an internal stage. So currently we support. So for example, if you have a CSV file or a Parquet file that resides locally on your computer, and then you're issuing the pandas on Snowflake, commands on your computer, then you can directly access that. So that's the same as what you're familiar with pandas, because like you could also work with CSVs and all of that locally. You could also do that with a stage. So if you upload a Parquet or a CSV file to a stage, you can also specify that path. And then in terms of external stages, we don't currently support like S3 buckets or like the S3 path directly, but it's definitely an area that we're looking into, depending on the use cases that we see in the field. So that's kind of how we're supporting that currently.
Fantastic. So we do have time for one additional question from the audience here today. And just so everybody knows, this is a fully live session here. So it's ask away, and we'll try and answer it. And so here we go. Here's another question. Any plan to update the feature of the pandas methods not yet supported?
Yeah, that's a great point. So we're actively working on, working with users, folks in the community to understand which are the kind of additional pandas methods that still needs to be supported. I would say that as part of our general availability, we've really prioritized a lot of the workloads and use cases that we've seen in the field, even to the point where we looked at sort of like the frequency of how these APIs are being used in the field. So we've tried to prioritize the ones that are most frequently used. And a lot of the times, most of the use cases that we are seeing are being fully supported. So folks are saying that they're able to basically copy and paste their existing Panda scripts and use Pandas on Snowflake with it. So we're already seeing huge wins there. Definitely a lot of work. We're continuing to work. Our team is continuing to work on these APIs and extending the coverage. And so if there are specific features or methods that you're interested in, feel free to reach out to us. We're definitely interested in like learning about your use cases and so on.
Fantastic. So as we wrap up here today, we've talked about all about the general availability of pandas on Snowflake. We've shown people a hands-on demo showing the performance gains and the developer and kind of user experience of using this directly inside Snowflake on Snowflake native notebooks. That was a nice thing to see as well. So as we wrap up, for people to get started, where do you go? Places you should check out is developers.snowflake.com. That's kind of your central hub for all of these various assets. You should also check out the documentation on docs.snowflake.com. And lastly, be sure and check out the quick start for getting started with Pandas on Snowflake. That walks you through step by step setting this up in your own Snowflake environment. So with that, I want to say a big thank you. My name is Daniel Myers, and thank you also, Doris, for joining me today.
Yeah, thank you, everyone. Super excited for you to try this out.